What existed before the Big Bang? It's the one question science may never answer, and anyone who claims they have the answer is, put simply, lying.
We've recreated temperatures of 7 trillion degrees inside particle colliders, peering back to when the universe was a trillionth of a second old. And yet, what came before that instant remains completely unknown.
A universe trapped in eternal compression, hidden dimensions beyond our reach, infinite bubbles of reality. These are the best ideas humanity has about the moment before the Big Bang. And this is the story of how far we've come in searching for answers.
And then there's that question. The one we might never be able to answer. It's frustrating. Incredibly so. I know. But we love pushing boundaries, don't we? Throughout history, we found answers to questions everyone said were impossible. So let's ask it one more time and take a look at what we actually know.
Yes. What was there before the Big Bang?
It's an incredibly difficult question. At its simplest, it's almost like asking, what would it be like if we weren't conscious? If we weren't thinking beings? I know it's not exactly the same, but think about it. We can't know, because we are the very consciousness capable of asking the question. Another impossible question. Anyway, let's start with what we actually have. While we don't know much about what came before, we know quite a lot about how it all began. As we've discussed before, here's a quick summary of what we know. First, we know that the observable universe was once much smaller and hotter, and that it continues to expand. We also know roughly when this expansion began, 13.77 billion years ago. For about 50 years now, we've been aware of the CMB, the cosmic microwave background. It's essentially the earliest photograph we have of the universe's history. This photograph is actually the radiation reflected from the Big Bang as we understand it. It emerged when the universe was still a baby, just 400,000 years old. That's only 0.003% of the universe's current age. If you compare that to an average human lifespan, it's like a photograph taken about 10 hours after birth. Although our visual reach only extends back 400,000 years, we actually know quite a lot about what happened in that earlier period. In particle accelerators like the Large Hadron Collider, we can understand why the universe was so incredibly hot in its earliest moments. When we smash lead nuclei together, we observe temperatures reaching 7 trillion degrees Celsius. This allows us to recreate and observe conditions from when the universe was just a trillionth of a second old. So, these are the facts we have. We possess proven knowledge about what the universe looked like when it was just 10 cubed seconds old. Let that sink in for a moment. That is truly remarkable, a testament to humanity's refusal to accept limits. Now, let's talk about what came before, the 0 point and beyond. Here's the honest truth. We know absolutely nothing about what preceded that moment. It's pure speculation. And unless physics makes an extraordinary leap forward, we may never know. That much is certain. Science cannot tell us anything about this period, at least not with evidence to back it up. And there's absolutely nothing wrong with that. Not knowing isn't something to be ashamed of. What's truly shameful is claiming to know when you know nothing at all. But there are some ideas out there, and we're going to explore them. First of all, the observable universe in the beginning was, of course, much smaller than it is today. But when we account for the parts of the universe we can't observe, the farthest corners we'll never see, we believe the total universe is at least 500 times larger than what we can detect. Explaining this mind-boggling scale and the universe in general in 3 dimensions is quite difficult, so let's look at it from a one-dimensional perspective.
If we show the observable universe as a single line with us at the center, the rest of the universe is at least the area of this circle surrounding it. That's how the total universe compares to the observable part at a minimum.
And the most likely scenario is that it's far, far larger than even this. In fact, this circle could be infinitely large.
When we focus only on the observable universe, it looks incredibly tiny at the very beginning. Everything we can currently see fit into this space.
But pay attention here. This area was not 0. That's a common misconception. It wasn't 0, but it was extremely small. So, what did the universe look like in this incredibly tiny space? Here's what we know. The laws of physics as we understand them simply didn't exist back then. That means it's impossible to describe what the universe was like using anything we currently understand. But perhaps, just like in space-time today, it was a place where matter and energy were constantly popping into existence and vanishing again. Space-time is one of the most misunderstood concepts when it comes to the Big Bang. In such an incredibly dense environment, with everything compressed into an impossibly small space and near infinite gravity, most people assume that time simply stopped. But if we were somehow there, time, assuming such a thing even existed, would have flowed perfectly normally for us. An outside observer would see us standing perfectly still. But then again, that's just relativity. It's also commonly believed that space-time itself first appeared with the Big Bang, that this explosion produced space-time. But at a point where all laws of physics break down, at a point where, from our perspective, time equals 0, we should hesitate to even claim that time was 0. In other words, trying to describe this moment, what came before the explosion, and its earliest instance, using our current knowledge will inevitably lead us astray. Still, let's take a look at some ideas about what might have existed before this explosion. 3 of them stand out in particular. The first idea about what existed before the Big Bang suggests that the universe existed in a perpetually compressed state for an infinite duration before the explosion and expansion, like a spring pulled taut, held in constant tension. Then, it experienced one of the quantum fluctuations we observe in quantum mechanics, and transitioned into a state of expansion. This concept isn't actually that different from radioactive decay, where particles shift from a stable state to an unstable one. This idea proposes that what came before was static. It's hard to wrap your head around, but it suggests there was no before, no beginning. It simply always was. And then something happened. Which of these ideas resonates with you? A universe that simply always existed, or something even stranger? Share your thoughts in the comments. And if you want to keep exploring these cosmic mysteries, make sure you're subscribed. The other ideas envision a much more dynamic pre-explosion universe. To understand them, we first need to think beyond our 3 spatial dimensions and 1 dimension of time. We know there are theories that predict the existence of these additional dimensions. And if they're real, there could be entirely different universes within them that we simply cannot interact with. Let's think about this more simply. Even though we believe we live in 3 dimensions, compared to birds, the surface of this planet offers us essentially a 2-dimensional experience. Birds are the ones truly living in 3 dimensions. If these interactions and additional dimensions exist, perhaps our universe was always there. It just existed in a different dimension. And in a sense, the Big Bang was the moment it transitioned into the dimension we currently inhabit. Imagining how we could ever prove this through experiments is extremely difficult. However, some testable ideas have been proposed within this framework in the past. The final idea about what preceded the universe is eternal inflation. In this concept, you can think of universes like bubbles in water. Bubbles that burst, scatter, and merge with others. Within this framework, our universe might be nothing more than a single bubble inside a much larger structure. And alongside ours, countless other universes could be byproducts of a parent universe, something you can think of as a vast cosmic pool. I know. Proving any of this with our current knowledge and technology is virtually impossible at this stage. That's why it's so important to treat these as ideas and speculation, not as theories or laws. When even saying that time was 0 at the moment we think time began is itself questionable, you understand the challenge we're facing. What's more, we don't even know what the universe looked like before the 10-cubed second mark. Calling any claim about this period even a guess would be remarkably bold. But what's being done to crack these codes? Reaching higher energies is the #1 goal. To understand that moment and what came before it, we need to go far beyond the energies and discoveries our particle accelerators have achieved so far. In the coming years, a collider far larger than the Large Hadron Collider is being planned. We'll talk about that in a dedicated video, but perhaps it will be the key to unlocking some of these answers. At the same time, we should be prepared for discoveries that could completely overturn everything we're discussing and thinking right now. Or perhaps we'll witness the confirmation of ideas that have sounded absolutely absurd to us until now. In short, science cannot offer a definitive answer on this subject, unfortunately. And anyone who tells you they have the answer is, in the simplest terms, lying. Yes, as we said, we know a great deal. We have a clear picture of what happened from 10 cubed seconds after the Big Bang onward. But no, we don't know everything. And the beauty of science lies precisely here. It clearly shows us what we don't know. My hope is that those of us gathered here will live to witness at least some of the answers, even if not all of them. I want to close by saying that I hold a utopian belief that humanity's only concern should be this search for meaning. And as always, until we meet again, I'm glad you exist. Take care.